Okay, here's a nice little problem with resistor simplification. Okay, so we're given a little circuit, looks like this. So there's nodes A and nodes B, and then there's a whole resistor network connected across this thing. Oh, there's one down here too. And so this is a 2.5 ohm, this is a 26 ohm, this is a 3.4 ohm. There's a 6 ohm here, there's a 20 ohm here, there's an 11.25 ohm, there's a 75 ohm here. And they choose these values to get the math to work out nicely. And these go way back to before we had calculators, and people, engineers wanted to work this stuff in their head. At least engineering students did. In real life, you're not going to have such nice values. But anyway, so draw out the circuit like I'm doing. Be neater than me. I am under kind of time constraints. I'm trying to do something a little different. So look, there's parallel and there's series, right? And a few students every once in a while have trouble. What's the difference? So look at the nodes. Like if you have a node A and B, and you have two resistors, this is parallel. So like here, take R1 and R2, and look for R1. Look on either side, and on either side of R1 you have node A and you have node B. And then look on R2, either side you have node A and node B. They have the same nodes on each side, right? There's only two nodes here, and resistor 1 has the same two nodes as resistor 2. They both have the same two nodes. So with series, there's going to be a third node. So like I could have C, D, and E. So here resistor 3 and resistor 4, these are in series. So now this is easier to see, but sometimes it's not so easy to see, in the more complicated circuit. That's why I'm doing it this way. But like here, take R3, it has C and D. Take R4, it has D and E. Okay, R3 and R4 only share one node. That's series. If here R1 and R2, they share two nodes, it's parallel. All right. Another thing, when we have parallel simplification, the R equivalent is it's the product over the sum. First of all, you can put this formula in your calculator if you want to take the extra time, because this is the kind of thing you do so much that it's nice to just enter R1, enter R2, enter, and solve, and then have it spit out the value. What I'm going to do, I'm going to use this notation R1 in parallel with R2. I'm just going to draw two parallel lines because it's faster than drawing this out. But, I'll get the answer. Okay, so this is just a notation here. It's just a shortcut notation, and you can use that on your homework if you want. I'll know what you mean. Anyway, so what we're going to do here, we're just going to go case by case, pair by pair. Now, that's what I want you to do. I know it's possible to write this all out in one equation. Chances are you're going to make a mistake. Also, it's hard for anybody to see what the heck you're doing. And thirdly, that's what the answer book does. And the more your homework looks like the answer book, the more points I'm going to take off. Ideally you shouldn't even look at the answer book, but I know the answer book's out there, and I wouldn't look at it. If you want to, for your own good, don't look at it. But if you need to, if that last resort, do what you have to do. But in life, generally speaking, the more you stress yourself, well, the harder the more you challenge yourself. The more you challenge yourself, the better you're going to do. So anyway, do it by pair by pair. Okay, do it by pair, and then redraw the circuit. Okay, so this guy, and I can do an equal sign like this, right? This guy, let's look here. These two are in parallel, right? Like if I label this node C and D, then resistor 3 has nodes C and D, and resistor 6 has nodes C and D. So 3 and 6 share the same node. They're in parallel, right? So I can write over here. I can say 3 in parallel with 6 is 2 by because you know, the product of 3 and 6 is 18 over the sum is 9. 18 over 9 is 2, right? Just applying this formula right here. Okay, and then these two guys, 15 and 5, they're in series. Like if I label some more nodes, 5 has nodes D and this is an E. 5 has nodes D and E, and F has nodes E and F, so they share only one node. They're in series. So a 5 plus 15 is 20. Okay, then you can imagine the 5 and the 15 as just being a 20 ohm resistor, and that resistor would be in parallel with 60. So we could go ahead and do one more step before we redraw. 20 in parallel with 60. The 20 equivalent here is in parallel with that 60. That's going to be 15. So now we can redraw. Okay, so you could redraw more often if you want, but please redraw no less frequently than what I just did, please. So here's node C and node D. I simplified the 3 and the 6, which are between nodes C and D, and I ended up with a 2, right? And this guy's, the 20 is still there, and the 11 is still there, and the 75 is still there. Oh, so you know, what are we trying to do? We're trying to find the resistor AB equivalent. So we're trying to find a single resistor across AB that's equivalent to this whole network. Right? Sorry, I should have said that at the very beginning. Okay, then between nodes E and or D and F, we replace that with this 15 guy. So I'm going to draw it over here. This is the 15 ohm, and the 10 ohm is still here. And if it helps, you could just label that F, because we replaced between D and F, we added the 5 and the 15. We got 20, and then we did the 20 in parallel with the 60. Okay, the 20 in parallel with the 60. And we got 15 between DF, so I drew it over here. Just kind of moved F up around this way. That's cool, because there's nothing in here. You can do that. If you want, I mean, you can think of this as also being F. If that makes you feel any better, because they're the same node, because this is just a wire. Okay, so there's that first level of simplification, and then we can look at some more things to simplify. Like right here, we've got the 15 and the 10. They're in series, right? Because they share node F only. This would be node G right here. So we can just add 15 plus 10 is 25. And the 25 would be in parallel with the 75 at that point, right? This 25. And if this is a little bit fuzzy to you, then just redraw the 15 and the 10 as a 25. And then you'll be able to see by looking at that picture that they're in parallel. So sometimes it's hard to see. If it is, draw more, okay? But I'm skipping, I'm just doing 2 steps at once. Like I say, draw more if it gets confusing. And ideally, you could redraw it after every single transformation if that's what makes it clear. But the point I'm trying to make is you got to keep it clear in your head. And if redrawing it every single time is what's required, then do that. that's generally speaking the way to think like an engineer is keep breaking it down into smaller and smaller pieces, so that as long as you're staying clear, don't make it harder than it has to be. All right, where are we now? So okay, I haven't done this 25 in parallel with 75. That's going to be 18.75. And now I could redraw this guy. This is going to be equal to, most of it hasn't changed. The 2.5 is still here. The 26 is still here. The 3.4 is still here. This guy's there, and the 20 is there, and the 11.25 is there. And what I've done is between nodes D and G, I've replaced that whole thing with an 18.75. Okay, then we have the same little problem in this little neighborhood right here. This is G, this is D. Let's call this H, node H. So right in here we have the same thing. We have two guys in series, and then whatever that equivalent's going to be is in parallel with the 20. So 18.75 plus 11.25, that sum in parallel with the 20. So another little notation that you could do. I wouldn't want to go any more than these two steps here, a series simplification and then a parallel simplification. I wouldn't want to go further than that before you redraw, but you could also redraw between both of these. So that's going to be 12. That's how they pick these numbers, so that you get a nice thing like 12. So this DH thing is just a 12, so we redraw. So the 2.5 is the same, the 26 is the same, the 3.4 is the same, then the 2 is still here hanging out waiting for something to happen. And between D and H, we've replaced that with a 12. And you could, just to show you another way to draw it, you could put it here if you want. Here this one I moved it down here, but here I moved over this way, They're the same, right? F is the same note. I could have drawn the 10 going that way. It's a similar kind of thing. Just showing you that you can draw it in different ways. And if it's not clear in one particular way, then you feel free to redraw it so that it looks more clear to you. Okay, keep a clear head. What's next? Same problem over again. We're just solving the same problem over and over again. So this is H. This would be, let's call it J. Right? So we've got 2 and 12 in series, and then that resulting equivalent would be in parallel with 26. So 2 plus 16 in parallel with 26 is 9.1. The number, it's not a nice number. But then we redraw one more time. So A, $2.5, B, this is 3.4 and 26. Oh no, this is 9.1 now. This is 9.1. Okay, then we've just got three guys in series. And let's see, this was J and this was H. So I could add all three and get all in one operation, or if that bothers you, you could do this guy and this guy, right? And then the resultant of that, add to this guy. Nothing wrong with that. You're not trying to prove to me how many steps you can do in one go. That's not the point. It doesn't impress me because that's not the point. See, generally speaking, the way engineers think is we take a very large problem and we break it down. There's always going to be a problem that's too big for you to solve in your head. So just showing me that you can solve 1,000,000 steps all at once in your head means nothing. It means that for a relatively simple problem, you can do that in one step. That's not the skill that's needed. The skill is to take a huge problem that doesn't fit in anybody's head and break it down into pieces that do fit in people's heads. It's even more than that. It's like imagine building something like a rocket or a computer. No single person understands the whole thing, so you have to break it into pieces and then take those pieces and break them down and eventually get pieces that are small enough for somebody to actually do. Anyway, so we can just put out the answer now. 2.5 plus 9.1 plus 3.4 is 15. That's the answer. Put a box around that. Okay? See you next time.